Hello guys, um, good evening or good day or good morning, whatever time you are watching this video. Okay, so based on the requests of some of us on the assignments, on the course 1 and 2 assignments, so be taking us through it and how to go about it. So first of all, I think let me just get I don't even know where I put that stuff. So we're asked to create a get a question. We're asked to write an object-oriented program that calculates beta input for x and for a set of values actually. So let me okay, so what we were asked to do is to write an object-oriented program. So if you if you don't have VS Code, you can just use an online compiler. And if you have VS Code, you can just open your VS Code and maybe create a new file. Then you can name it beta underscore calculator. Then you add the file extension CPP, which stands for C++. So in my first line here, I have include IO stream, which is I think we should know this by now, which is an header file which contains declarations to functions and other components for input-output operations. Then we have, of course, here I have my main function, which is the entry point to the program. So like I said the other day, the main function is automatically being called by the operating system actually. So whenever you run a compiled C++ program, that does not have main function, you get an error. Main is not defined or cannot be referenced or something like that. So which means that whenever you run a program like this, your operating system is calling main function. So it's just like a system call. So a system call is just is an operating system level function call. So maybe later we can, maybe in the future, we can get to that. So for every program, we are supposed to have the main function, which returns an integer, and this integer it returns stands for the status of that program. So usually for complex programs, we can decide to return 1 or return 0, -1 or so, and that depends on the nature of the problem we are trying to solve. So if for instance now, let's say you are writing this particular program to solve a particular problem, and you need to know if something happened in the course of at runtime, like in the course whereby the program is running. So you need to somehow get status from it. So that's just what this return 0 is. So normally in programs, majorly most programs return 0 when they run successfully. But if they run unsuccessfully, it can return 1, or it can return what's it called, negative value or so. So I don't know if anyone here is conversant with Linux. So for instance now, if I try, okay, now since I don't have internet connection, if I try to call google.com, sorry for digressing, but I'm just trying to give you an idea of what the main function does. So if this call here is just like a way of like making what's it called, sending an internet request. So I'm calling google.com, like I want to get the content of that web page. So if I run this, I should have an error because currently I don't have a strong internet, or if I can even interrupt it, but I want it to fail. So I can now show you something. Let me interrupt. So now you can see here in VS Code terminal, you can see this red stuff that that has X inside of it. So to tell you that either the process was interrupted or it failed. So in Linux, if I want to get the status code of the previously ran command, I just simply do this and it gives me the status code, which means 130. So let's say I run, and I think this is for interruption. So let's say I run a different command that runs successfully, let's say ls for instance, to list whatever content that I have in my current directory. So it lists everything I have here, my a.out, average, beta, whatever. So if I run the same echo again, I should have 0. So you can see here, main return 0, which is the, so because this my ls ran without any error, so it returns 0 automatically to show success. And you can see here this blue dot here showing that the command I ran was successful. So I hope you get that. So which is why one of the reasons why we returned 0 in our main function, to tell whatever program that is calling our program, or to tell the operating system that yes, I have run successfully. So back to the tasks of the day. So we're asked to create an object-oriented program. So when it comes to object-oriented program, we talk about classes, we talk about attributes, we talk about methods. And before now I said methods are functions, but they belong to a class. So for this problem that we were asked to solve, we were told to calculate for beta value of regression or whatever. So which means we are required to create a class which we then contain functions or methods that will solve those problems internally, and also create instances and make use of instance of those objects. So yeah, I'll first of all create a multi-line comment. So to create a multi-line comment, you do / then double asterisk, and yeah, like that. So you can just use it to document, well, maybe your intention or what the program is about, basically. So I'll just write the formula there. The beta is equals to sum of xi and yi, then subtracting the, what's it called? So yeah, where the formula is first of all sum of what, the product of x and y, and subtracted, we now subtract the sum of xi from it. So the program is supposed to take set of values of x and y, then from the formula we have to sum the products of xi, like each set, sum it, then sum for x entries also, and also Okay, yeah, forgot something. Then we'll sum for x separately, then sum y separately. You get? So we have here we have sum of the product of x and y. Then here we have sum of x only, then sum of y only, that will now multiply, then which will now be subtracted from sum of the products of x and y. I hope we get that. Then it will now be divided by, let me have precedence so that you know that whatever is inside. So all this now will be our numerator, then our denominator will now be sum of x I squared. Here's my caret squared, then divided by I think I'm making a mistake here. So sum of x, product of xi, sum of minus sum of xi times sum of y. Okay, there's a mistake here. Yeah, correct. Sum of xi times sum of this. Then the product here will be divided by n, and then this is okay. Now from all this now to this point is a numerator, then from here will now be our denominator, which is sum of xi squared minus sum of xi squared over n. So sum of xi squared minus sum xi squared over n. So this is just the syntax for the formula we'll be using, although we'll try to break it down to in order to make it less complex, something like that. Then now what is the first thing we're going to do? Now we're going to define our class. So normally we are supposed to just maybe have a draft or a pseudocode of how of pseudocode of the program, then then we now move to implementation. I don't think we have much time for that. So I forgot something here. So we'll be using the namespace of the standard variable, so that whatever variable or whatever variable or function we are using from the standard library, we just call it by name instead of having to add something like this, stand out, the std, then double colon. So this one will be more bulky, so we just add using namespace. So here now we have to create a class for our beta. So what do we do? Let's just indent it. So we'll name a class, we'll call it beta calculator. So this is what we call a naming convention. This is in a camel case. Is it camel? So normally naming conventions, when you are naming a class, you start with a capital letter, and if it is a multi-word, the next word will be a capital letter. Like the first letter of the next word should be a capital letter also. So now we have to put the I can't remember what we call this thing again. This public stuff. Access specifier, yes. So this access specifier is just it just specifies how the attributes, whatever attributes of that class can be accessed. So whatever attribute that we define under public can be accessed outside of the class. And so what does that mean? It means that when we create an object, so whatever attribute that is under this public are those attributes that we can access when we are out of the class definition. That is, when we create an object, let's say for instance now we have okay, I'm going to use some of the values that we have here already. So let's say we have int sum of x, sum of x, right, sum of x. Let's initialize it to 0. So if I int sum of x, so let's say now if I create an instance of this beta calculator, I can only access sum of sum of x, you get, from outside of let's say I create an instance here. Let me do beta calculator. Let's say beta, let's name it beta, let's name our object beta. So I can just declare like this. Since I don't have a constructor, then I can access whatever value. So let me see out sum will be, let me also append, then I'll do beta dot sum of x, then I can add my end of line character. So let me save and compile. So if you are on an online compiler, sorry, mind my English. If you're on an online compiler, if you're using an online compiler, so just click the play button. I think there should be play buttons over there. Or if you're using VS Code and you have G++ compiler, so all you just have to do is G++, then the name of the file, which is beta calculator.cpp. So you can just do tab. Okay, just do tab. Then okay, there's an error. I'm supposed to have a semicolon after my class definition. So let's compile again. Boom, our stuff work. So since I compiled and I didn't specify the name I want to save my executable file as, and we automatically to be saved as a.out. So to run it, I will do /a.out. If you are using Mac or Linux, this is how you do it. But if you are using Windows, you have dots, then / instead, a.out. So if you are using Linux or Mac OS, this is how you do it. So here you can see that we were able to access, we printed the sum value which we initialized as 0. So let me show you something interesting. I'm not going to initialize my sum of x, then let me compile again, then I'll run again. See what happened? We didn't put any value in sum of x, but we have a value here, 32,765. If we run it, we'll get a different value. You can see. Why does this happen? This happens because in C, actually, when you declare a variable, so you just tell it that, okay, help me find a memory space, a space in the memory that where I can store an integer. But in that space, there can be anything there. So there is a value there. Most programming languages don't allow this. For instance, now for Python or JavaScript. So when you don't just when you declare a variable, I don't know, sure, but when you don't initialize your variables, there's automatically a dummy data. So you always make sure you initialize your variables before you use them, so that in order to prevent them what's it called, some kind of error whereby you'll be seeing what you're not supposed to see. You'll be like, but my programs are correct now. Well, it's just some initialization problem. So now let's create another variable in sum of y. So initialize to 0. Then we'll have int sum of products. Sum of product of xy. So sum of product xy, we just initialize this one to 1, so that y I can't initialize it to. Okay, that should work. I can put it to 0 since it's addition. So anything plus 0 will give me back that thing. Then, which other variable do we need from this formula? We need the sum of x squared. So int sum of x squared, which is int sum of x squared can also be 0. Then we have sum of y, we have sum of x, sum of the two products, sum of x squared. Okay, I think that's all we need. And we need n also, which is the number of entries that is required. So yes. So now we'll have to okay. So now these variables are attributes. So these variables here, I can't use them here outside, like without having an instance. I can only access them through beta because it is the direct object of the class. So which definitely we have all these as its attributes. So this is under a concept we called scoping. So whatever we define under a class belongs to that class and can only be accessed through the objects of that class. So now we are going to create a function or okay, let's create a constructor. We will use a constructor. So constructor is like a method. Is a method or a function that just prepares. That's the first things that run whenever you initialize or you instantiate an object of a class. So what does instantiate mean? When you create an instance of a class, so the constructor is the thing that runs first. So just like our main function in our program, which is the first function that runs first when we run our program. So the constructor is the first function that runs when you create an instance of your, or an object of your class. So now, in order to create a constructor, we won't add anything, no return type, nothing. We use the same name the same name of the class, which is beta calculator. Then we will pass arguments to it. So what's it called? for this problem we'll be using, we'll pass two arguments. I think, should we pass 2 or 3? We'll pass 2 arguments. So we'll first of all specify the data type of the argument. So here we are specifying a constant vector. So we are using a vector for this. So what is a vector? A vector is an array, but not just an array, a resizable one. So maybe later in the future, maybe later, sure, we'll learn about that. So like basically, when we have an array in C or C++, we have what we call pointer, and whenever we deal with pointers, we deal with what we call memory allocations. So memory allocation is just like when we allocate memories, so pointers, for instance, now let's say you have a function whereby you so we have a vector here. So a vector, like I said, is just a resizable array. It's just a container that can adjust itself. So that's just basically what it is. So here we will pass the address operator, which is the ampersand, then xi's. So I'll say x, then we will pass we will give another parameter for y. So say vector integer. So vector here is a data type. No, it's not a generic one. It's not a what's it called, primitive data type. So it's more like a complex one, which has to do with pointers and memory allocations. Then here we just specify that okay, in this vector or in this array we want to store integers. So that's why we have vector, then this greater than, less than, less than, greater than, then int. Then this ampersand, this is just to, this ampersand here is like having, it passes the address, like the memory location of the vector. So in when we have vector or array, it's just like we have a variable, for instance, is binded to one location, right? So when we have an array, we have several memory locations which are joined together. It's just like a block. So, and whenever you pass the address of a vector or whatever, we are passing the first memory location. So from there we can shift forward and be going like that, like from each box to each box, and so on and so forth. So we should have here y's, then we pass our curly braces. So this is just like a basic form of creating a function. So we specify the data. This one is just to tell you that it's a constant. We don't want to change the value. Then this one is just the data type, and we type it as an array of integers. Then this ampersand is like I said, is the address operator. So it's a way of modifying the data inside a particular memory location. Normally we cannot modify, let's say now when we have a function, right, when we have a function and we have the parameters, right, so the parameters are just a way of, when we pass our value, they have a copy of whatever value we pass, so they cannot modify it. So okay, let's say for instance now we have, let me create a function now. I will say int change x, okay, int there, something like this. So I'll try to reassign the value of x to 10, right? So here I will create an integer. Let me delete all this. Okay, let me still leave better. I'll create an integer x, or let's say a, then I'll assign 5 to 8. Then I'll now call this function change a. After that, I'll try to print the value. Then here I will say the value of a changed. The value of a changed to blah blah blah. So I will append a, then end of line. So let me save and compile. There's an error. Class with why no matching call. It's because I created a constructor here. I declared, but I didn't create an object. Let's remove that line first. So let me compile it again. What's going on? Oh, sorry. So I need to include vector. Where's my hash? I need to include the header file vector, which contains the references to the components of the vector object or vector data type. So let me compile it here. Oh, wow. No return statement in the function, no void. Which one is that? Not this one. No, there's no return type now. Okay. So I'm meant to return anything, so that's a constructor. Which one was it pointing to? Const vector, it's changed, no return type statement. Oh, I see. So I'm supposed to return, since I specified that I should return an integer. So here I can just, okay, let me change it to void, since I don't want it to return anything. And I'll return this, I'll remove this in the return statement. I'll save, then try to compile again. It should work now. So if I do a.out, what happened? Change this to void now. It's working. So here you can see that when I reassigned x to 10, the value didn't change, so it was still 5. So what that ampersand does is that if I pass the ampersand of x now, then of x to this, then I can reassign the value. Of x to whatever value I want. So here when I'm passing it, I'll just pass the, I think the address, yes, the address of it also. So I think what W school call it is the address operator. So just pass the, here's my address operator here. So let me compile and run. Oh geez. Int these two ints. Cannot bind R value to int. Don't forget to use this thing. I can't Google it now. Okay, it works. I'm not supposed to add anything there. So since it's, yeah, so let's run and see. You can see that A is no longer 5, it is now 10. So if I remove this now, if I compile, I run it again, I should have 5. So that's basically what that ampersand does. It's just the address operator to modify the content of a variable, like from another function, because a function does not, like, naturally they just copy the content of a variable. So moving on, we instantiate our stuff. So in this place here, what we want to do is that when we instantiate an object, we want to set up whatever variable or whatever attribute that we need beforehand. So that's what happens. So here, what we are going to do, we want to set up, initially we have sum of x to be 0, sum of y to be 0, and of course sum of whatever this is to be this and that. So here, what we want to do is, first of all, we want to get the size of this array. So we do int n is equals to xs. So because the size of x and size of y we expect them to be the same, so we just take one of them and say ss.size. So a vector object is a vector array is basically an object, so it has a size attribute. So we access the size here, so it will tell us the size of the array. Then we will use that size in order to compute the sum of x and the sum of y, and also the product. So we then do, in our for loop, we just say int I equals to 0. Then we now add our condition where I is less than. Then we pass our increment or decrement. So we just have to do that. If not, it won't work safe. So now, what do we want to do here? We want to sum we want to sum every value of x and every value of y contained in this array. So which is why we have sum of x should be equal to sum of x plus xi. So what does this mean? This x then I. So here In programming, whenever we have an array, I don't know if any of us have seen a meme where a boy, a guy and a girl were supposed to be on a date, and the girl tells the guy to meet him at the first table. So instead of the guy going to the table with number 1, instead he went to number 0. So yeah, that's a programming meme, sure. So here in every array, the first object is the index of the first object, or the position of the first object is 0, then the second 1, 2, like that. So position starts from 0, then upward. So now we want to access the first object, or we want to access each object in the vector array. So which is why we do s then square bracket is to access a particular object in a particular position. So here we initially want, and for instance now, if an array contains 5 objects, right? If it contains 5 objects, that means the positions are from 0 to n-1. So the last object is what? If we have 5, if we have an array containing 5 objects, we have 0, 1, 2, 3, and 4. So, which is why we have I is less than 5, less than n, because definitely n-1 is less than n. So here we want to sum. Our initial value of sum of x is 0, right? We want to sum every value. Like when we get to the first one, we add it to the previous, add the second to the other, then like that and like that. So we'll do the same for the values of y. Sorry. We'll do that for the values of y. So we'll do the same thing, sum of y plus y's, then like that, you get. Now what else do we need to do? So we just want to also sum the product of x and y. So we'll do sum of product xy is equals to sum of product xy plus what? That's x, then times that's y. That's y, the current y. So here let's parenthesize it. What's the precedence of? Okay, it doesn't matter. So we add a semicolon. Then we do the same also. We check for the sum of x squared. So x squared. We also do the same. So x squared plus x times x. So that's just it. This is just what we want to do in the constructor. We just want to set up the variables of that stuff, so we can so we can access each of these values without like after any instantiating our object. So next thing now we want to do is to do the computation part. So now what do we do? So we create a, excuse me, so we create a method, let's say we'll call it calculate beta. Then it will take, what is it going to take? It's not going to take anything, because most of the data we need are already here in this place here. They are already defined within the objects. Immediately we even instantiate the object, you get. So we have this. So if your AI don't come again, if you have a function that takes nothing and returns nothing, you just have the void data type. But here we want to return something to the caller. So, and we need a decimal, a floating number. So we can either use float or double. So for the sake of precision, we need to use double. So because double has more decimal places actually than float. So which makes double occupy more data storage than a float data type, which is 8-bit. Is it 8-bit or 8 byte? Whatever. And yes. So now what do we want to do? We just want to compute the beta and return. So what we need to do, we create a numerator. So we use the double data type also, numerator, or we call it numen, is equals to, then what's in our numerator here? So let's just copy and paste here.
Or more right, I'm fresh. Okay,
we can do that. So what should be in our numerator? Our numerator is basically the sum of the product of x and y. So we do sum product xy. I did a typo here. Sum product xy, then minus sum of x times y. No. Okay, sum of x times sum of y. So we do minus sum of x times sum of y, then divided by n. Is n as available to us? Yes, it is. We initialize it here. So yes, it is available. So because what we have here, they are in the higher scope within this class definition, so we can access it, you get. So that's why I'm able to just call sum of products like that and call sum of x like that without having to worry whether they are accessible or not. So because they are within the scope of the class and the method definition is underneath, like it's inside the class, so that's why I can do that. So now we have double the num, so we should have I'll check whether they talk to myself since. Okay, so sum of denominator will now be, our denominator is sum of x squared minus sum of x squared over n. So sum x squared minus, we'll parenthesize this in order to, because of precedence, for no go soft nonsense, sum of s squared over n. Then here we will now return numen Bam. So now let's create an instance of our object. So what we will do here is okay. Oh, I didn't have that. Beta calculator, beta. So this one now we just declared beta like this. So if we, although we can still, without creating an instance, right now we've not created an instance yet, but yet we can access. Can we? Let me try that. Then we can access the values of beta. So let's do beta dot sum of product of xy. Let's compare that around. Let's see. I didn't instantiate it, so I want to see what happens. So expected candidate expects 2 arguments and this. So whenever you, if before I did not have this constructor, I should be able to access all this. But since I have a constructor, definitely I need to pass the necessary data and initialize our object. So which is why I'm going to have something like this now. When I have beta dot calculator, then I'll pass my vector. I can just let me go with AI suggestion for the suggestion. 1, 2, 3. Then let's see. Compile. I have an error. Return number. Expected a semicolon. There is okay here. Which other one? I think that was all. Let's run it again. Okay, another product, another error. That size error. To return type int. Long consent int. Vector costs. No expect. What's this one saying? Okay. Let's see what happens. Oh, okay. So this was supposed to be a method, not a variable attribute. So the size is a method, not a variable attribute. So I need to pass these parentheses. So now it should work now. Let me try my terminal. So let's run it. Then display. I'm running correct. Data value. Data value 32. Zona 1, 2, 4, 2, 2. Okay, let me change 1, 2, 3, then 2, 3, 4. I have to check something. formula is wrong. Numerator of sum of product of x and sum of product of x minus sum of product of sum xy, sum x times sum y over n, then the norm should have the sum of x squared minus sum of x times sum of x. Oh, sum of x times sum of x, not sum of x times sum of x divided by n. So that's where the so now they call semantic logical. Still the same one. Sum of x squared minus sum of x times sum of x over n. Let me check. Sum of x squared minus sum of x all squared print it like this one. Sum xi sum of x, that's okay. Let me just do something simple. Here I'll use the augmentation operator because I don't think our beta value is correct in any way. Then I'll use augmentation here also. So this is just to do the same thing, like to add the previous value of this variable to whatever value that is coming here. So here we'll first of all do this side there before adding to reassign. So it's just a reassignment operator. Okay, 20. Let's assume the formula is correct. So this is just basically what it is, and sum of product of x minus this double by n. I put this one for bracket also. So mainly this thing is now returning okay, I want this thing to always be in decimal form. So what I just did here is to typecast, like to convert whatever it's just a conversion of whatever value I have here to, okay, if I do that, you know, go do them. You could not convert them, like we don't do them as integer already. So here I will just typecast this sum of x to decimal, so that whenever it multiplies and divides, I get back a decimal instead of it stripping the decimal point. I think I'll show us an example of that when finally connects to the standard input, so that we can enter any random variable. So here, so now, in order to make this thing an interactive one, not just a generic program, so we are going to connect, add just a few lines of code. So here, what we are going to do is to request. So we are going to create a vector object here, vector, so of integer. We are going to create two vectors. We have x, let's say xi or x. It's not going to affect whatever variable that is there. So it's just this one just belongs here. So x, then y's, like that. So when you want to create or declare a variable of the same type, even bunch of them, even up to 10, you can just do them like this, just separate them with comma. So now what we want to do, currently our x and y's are of size 0, there's nothing there. So now what we want to do, we'll first of all want to ask the user for number of entries. So say enter number of entries. So bam, here we don't need to add the end of line, so we are not going since we will be hitting enter, which will take us to the new line. So here we do cin, then pass the value to n, right? So forgot to do this, n. Yeah. Then after that, after the user has entered the value, we just do for int I is equals to 0, right? Then we add our condition that I less than n, then increment our I, then put our curly braces, then we now put the statement how we want to do it. So here we'll say int x, comma int y. We can actually do this line, we can take it upward, but we just want it to pertain to this we want it to pertain to this scope in this for. So whenever this for statement finish running, it doesn't need this xy will not be accessible outside again. So it's just, we can't access it from outside the for, but we can access whatever that is up here in the for. So I hope you understand that. So now we want to access, we want to collect each pair of x and y. So what do? We say cout enter pair, or just say enter for x. Then here we do enter for x, then pass I. Okay, I think that's it. Okay. To make it readable, we do this space colon, then in front of line, that's semicolon, then cin, pass it to x. Then let's do the same thing for y. Copy, paste. So then we change this one to y. We change this one also to y. So after we've entered, we now use the push method of the vector xs. Sorry, it should be x. We'll now push x. So this one just add the value of x to the stuff. Then this one we have push y as well to push it. So I think this should be all for that. Oh, it should be push back. Push back. Let's try push first. We'll try push. If you know what, try push back. So now after this, what do we want to do? We then create our instance. Beta, right? Beta calculator. Let's use small letter beta. Have you created an instance before? No. So now, in order to create the instance of this guy, we'll now pass to instantiate this guy. We'll now pass xs and ys. So here we'll now say beta value. Oh, you know what has been happening? Here, I thought it was, just imagine. Okay, let's pass back that. So before we were supposed to print, the beta value, like to calculate the beta. But instead we're printing the product of x and y. That was why we were getting 20, 20, 20. I was not like, so this thing all the work or something. So let's change to calculate beta. Then we'll now pass, we'll pass nothing, but put our this thing there. So let's run this. There should be an error, yes. So push is not a member in y. So the correct method is push back. And then we'll try push front, push back, push back, save, recompile. My bad. Okay. So we now run a dot out. Enter number of entries. let's say we have 4 entries. So enter the value of x. Oh, that's the first value of x. So let's say 1 for y0, 2 for x1, 2, this one, 3, this one, 3, 4, then 5, let's say 5 and 7. So look at our beta. So in order to confirm what was wrong that time, I was getting 0, 0, I did 2020. Let's see if I run again. Let's see for 1, 2. So we're supposed to be having a decimal, but it was forgot to change here. So we'll put this back, save, and we just make a little amendment here. So here we should have a space should come after the semicolon for the writing makes sense. So yeah, this is basically it. So yeah, okay, I forgot to change something. In order to make this stuff, to make this thing more user friendly, so I'll change this here. I'll increment this by 1, change it to 1, then change this condition to be less than or equals to 1, so that whenever it gets to n, it's still the same number. So instead, for I in the user interface or in the output, I'll be cutting 1 to n, which is 1, 2, 3 to n, instead of 0, 1, 2. But it will still be, yeah, just to like that, yeah. So I will save and recompile, then a dot out. Sorry, it's in the screen from here. A dot out. So number of entries, let's say I have 3 entries. So now we have x1, let's say 1, y1 we have 2, x2 let's say we have 3, y1 we have 5, x3 5, and let's say we have 9. So our beta value is 1.77, blah blah blah. Let me check something again. We have one entry. This one should be done 0 or even dump 0. It no go work. Okay, the value is 2. Interesting. Number of entries, 3 entries, 1, 2, 2, 3, 3, 4. So maybe at your own time you can just cross check this formula. So whatever the numerator should be, you can adjust at your own end, and the denominator also you can adjust at your own end. So let's see if this double is necessary or not. You can leave it up, or just trying to explore. Compare. 3 entries, 1, 2, 2, 3, 3, 4. So you still returns a decimal, so that will just make it ambiguous. So you can have it like this. Then also we can also do something different, where instead of repeating something like this, we can say cout enter pair. Cout enter pair. So here we just add colon. So see how to enter pair, then whatever value this one also just whatever value you have, you can just, because in cin you get whenever you have a space. So like if you enter two numbers 1 2, so it will store the first one in the x, then the second one to the y. So just to make this more simple, so instead what we are going to do now is enter pair, then in our have a bracket x space y, at least to give the user idea on how to write it. So like this, let's compile and run again. Number of entries, I have 3. Enter pair, I have 1, then 2, 1, then 3. Oh, wait, this number is 0. 1 dot 1 space 4 be 5. So yeah, this is supposed to be 0 because the number of x. So like I said before, just cross check the formula. So this beta value is supposed to be 0 because the value of x is did not change, and if we squared 1 squared minus what's it called, 1 squared is 1, then 1 minus 1 over the sum of 1s here is 3. 3 over 3 is 1. 1 minus 1 0. Then all this now divided by 0 should be undefined. So the formula, I don't know. Sum x squared, sum of x times this. Sum of x squared is 1 squared, 1 squared, 1 squared, that's 3. And sum of x squared itself, sum of x squared, sum of x, that's 3 squared, that's 9 divided by 3, which is 3. 1 minus 3 should be negative. Yeah. Okay, that's 3 minus 3 is 0. So this is supposed to be undefined. I don't know what happened. Okay. So that's just basically the approach. So any adjustments from your end, or you can just adjust. So I hope this was helpful, and I hope it makes it. I hope it is easy for you to understand. So yeah, happy coding.